It is Sunday evening at 5 o'clock, and I'm going to try to record this on my computer at home, which means I don't really have a good writing tool, but I can type and we'll see how this works. So this is your homework for quarter two, week 3, week of November the 3rd. And we are going over multiples and factors. So the first question is, what is the least common multiple, or LCM, of 8 and 12? And I've given you a hint here that says multiple is the result of what you get when you multiply a number by whole numbers. So for instance, the multiples of 8 are things like 8 times 1 is 8, 8 times 2 is 16, 8 times 3 is 24, 8 times 4 is 32, 8 times 5 is 40, 8 times 6 is 48. We'll start with those. And the multiples of 12, so 12 times 1 is 12, 12 times 2 is 24, 12 times 3 is 36, 12 times 4 is 48. So that gives you an idea. So now we want to look for the ones in common. So there's a 24 there and a 24 there. Those are in common. I'm going to change that color. I don't like that color. And then also we notice that they have 48 in common. But we want the least, which means the lowest in value. So the LCM of 8 and 12 is 24. Okay. Problem number 2. Maggie says the LCM of 8 and 12 is 24. That's what we got. Her friend Glenn says the answer is 4. So we know that Maggie is correct. Maggie is correct. Okay. Glenn is confusing multiples with factors. So that's Glenn's error. Factors are the numbers that divide into the number that you're given. Okay. Let's go on to the LCM of 2 and 5. So again, we're going to say 2 times 1 is 2. 2 times 2 is 4. So we're going to just be skip counting by 2, 6, 8, 10, 12. And multiples keep going. And the multiples of 5, 5 times 1 is 5, 5 times 2 is 10. And we could just keep skip counting this way, 15, 20. And the LCM, the one that is the least in value, is 10. So let's type that. Let's do this color. The LCM of 2 and 5 is 10. I think so far this is working with me typing. Let's keep going. A red string of holiday lights blinks once every 3 seconds, while a string of blue lights blinks once every 4 seconds. How many times will both sets of lights blink at the same time in 1 minute? So 60 seconds. So we're going to find all of the multiples in 3 and 4 up to 60 and see how many of them are in common. So the red lights, I'm going to do this here, red every 3 seconds. So that's 3, 6, 9, 12, 15, 18, 21. Like, this is like stressful having people watching multiply. 24. And then we're going to go to 27, 30, 33, 36, 39, 42, 45, 48, oops, 48. 48 plus 3 is 51. Plus 3 is 54. Am I right so far? Yeah, 54, 57, and then 60. Okay, put those there. And now let's do the multiples of 4 up to 60. So 4, multiples of 4 are 4, 8, 12, 16, 20, 24, 28. And if you don't do this as fast as I do, just take your time. 36, 40, 44, 48, 52, 56, and 60. So now we have to find the ones that they have in common. Let's go yellow here. Okay. So they don't have 3 in common. They don't have 6 up. Oh, they have 12. Now remember, these aren't going to line up exactly. You kind of have to look. So I don't know, 15, 18, 20. Oh, 24 here and 24 there. 27, 30, 30. Oh, look, 36, 36. No, 42. No, 45. Oh, 48, 48. Let's see what we got here. Hold on. 60 is going to be back there. So I know that 60 is hidden right there. That's 60. So how many do they have in common? That's 1. Let me just make sure that I have these all lined up correctly. Okay. So that's a match. That's one match. That's a match. That's a match. That's a match. That's a match. 1, 2, 3, 4, 5. So how many times will both sets of lights blink at the same time? 5. I'm going to try and finger it. Well, I'm actually using a mouse. 5. This is really tricky. Times. Okay, so 5 times is how many times they will blink in common. Okay. To make hummingbird nectar, you must use 4 cups of water to 1 cup of sugar. So what is the ratio? So the ratio is 4 to 1. Okay, you could also do it 4 to 1, or you could do, I'm going to try and finger write this, 4 over 1. They did not ask for it 3 ways, but that is it 3 ways. Going on to Tuesday, we find the LCM of 4 and 10. So we've done this a few times. The LCM is the multiples, the lowest multiple that you get. And remember, you're multiplying the number by the whole number. So for instance, 4 times 1 is 4. 4 times 2 is 8. 4 times 3 is 12. 4 times 4 is 16. 4 times 5 is 20. Now, when you do this, you might be like, oh, wait a second. I know that 20 is also a multiple of 10. I don't have to make the multiples a second time. But if you do, 10 times 1 is 10. 10 times 2 is 20. So you can make your multiples for one set of numbers, like I did there for 4, and then you might have enough number sense that you start to realize what the answer for the least common multiple is. But we're still going to do it the long way so that everybody gets it. So Kendrick says that the LCM of 4 and 10 is 20. That's great. His friend Drake says the answer is 40. So we know, because we just did this, that Drake, oh, neither of them are right. Neither. Oh, wait, hold a second. Kendrick, I thought it said 4. Kendrick is correct. Drake found a multiple, but not the least common multiple. So for instance, if I had continued up here, I would have gotten 20. I would have gotten 24. Move this out. 28, 32, 36, and 40. Let's put this over here. Okay, and if I had continued here, so 40 is a common multiple, but it is not the least. Okay, what is the least common multiple of 3 and 4? Multiples of 3 are 3. 3 times 2 is 6. 3 times 3 is 9. 3 times 4 is 12. Oh, okay. So I know 3 times 4 is 12. Let's see if they have anything less in value. 4 times 1 is 4. 4 times 2 is 8. 4 times 3 is 12. So the least common multiple of 3 and 4 is 12. Okay. Tom waters his cactus every 7 days and his fern every 4 days. On which days will he water both plants in the month of December? So we're going to find all the multiples up to 31 because there are 31 days in December. So let's go over here. Okay. 4 times 1 is 4, times 2 is, let's start with 7 because that's what they start with, 7. 7 times 1 is 7. 7 times 2 is 14. 7 times 3 is 21. 7 times 4 is 28. 7 times 5 is 35. We're not, though, I want to point that out, we're not going to use 35 because there's not a 35th day in December. Okay. Now we are going to find the multiples of 4. 4 times 1 is 4. 4 times 2 is 8. 4 times 3 is 12. 4 times 4 is 16. 4 times 4 is 20. 4 times 6 is 24. So the only one that these have in common is 28. Okay, so let me text this here, box this. On December 28th, he will water both plants on the same day. And number 5. Nathan is making a beaded bracelet. For every 5 red beads, there are 3 white beads. What is the ratio? So the ratio is 5 red beads to 3 white beads, right? Yeah. You could also do 5 to 3. And if I try to write it with my mouse, 5 over, whoops, 3. Okay, going on to Wednesdays. What is the greatest common factor? So we need to know that a factor is a number that can be multiplied to make another number. By another number to make a larger number. So I'm going to suggest for these that we make a T. No, I don't want that. No, and I don't want that. Whoops. I really want a line. Can I get just a line? So I want to actually make a T-chart for 54. And I'm going to also make a T-chart for 32. Okay. And I am going to text up here. I'm going to do 54 first. So I'm going to do the numbers that I can multiply to get 54. So I can do 1 and 54. Those numbers multiplied together will give me 54. I can do 2 times 54. So you might have to use your calculator. Divided by 2, if you don't know it, is 27. And I'm going to run out of room here, so let me make these a whole bunch smaller. Okay. Let's start this over. So 1 goes with 54. 2 goes with 27. Okay, does 3 work? So let's see. 54 divided by 3 is 18. So 3 times 18. Let's see if 4 works. 54 divided by 4 is 13.5. 4 does not work. 5 does not divide into 54. You guys should know your multiplication tables, but if you don't, 54 divided by 6 is 9. So I'm going to come back up here. That can be 6 times 9. 54 is not divisible by 7. It's not divisible by 8. If you don't believe me, you can actually do 54 divided by 7. Nope. Okay. So these are all my factors. Any of these numbers, 1, 2, 3, 6, 9, 18, 27, and 54, can divide into 54 without a remainder. Now, let's go over here and let's do 32. Okay, so we can do 1 times 32, 2 times 16. 3 does not divide into 32. 4 times 8. 5 does not divide evenly into 32 with no remainder. Neither does 6, neither does 7. 8 does. I already have 8 in my list. So these are the factors of 54. And these are the factors of 32. So which ones do they have in common? They have 1 in common. They have 2 in common. They do not have 3 in common. They do not have 6 in common. So the greatest common factor of 54 and 32 is actually 2. Let me write that better. Okay? Emma says the GCF of 16 and 12 is 48. Her friend Grace says it's 4. Well, right away, it can't be, let me put this over there. 48, it is not 48 because 48 is a multiple of 16 and 12. Now, let's see if 4 is actually correct. Let's just check it. I think it is, but let's make sure. So we want this, make some T-charts. So there's lots of ways to do factors. Some people, a lot of teachers do it like in parentheses, and I have been doing that in class, but I feel like kids aren't getting that factors kind of work in pairs. So for instance, to get 16, you would multiply 1 times 16, or you would multiply 2 times 8. 3 does not divide evenly into 16. It's not a factor. 4 does. And 4 times 4 is 16. So that's where these end. Okay? Now, let's look at 48. Okay? And my son is coming into the kitchen, but you cannot talk, son, because I am making a video. So 1 times 48 is 48. 2 times 24 is 48. 3, is 48 divisible by 3? Let's look. 48 divided by 3. See, sometimes we don't know these. It is 16. Oops, let's go back over here. 3 times 16 is 48. 4 times 12. 5 is not divided into 48. 6 does, though. It's 8. Okay? So actually, Grace is not correct either. Let's put that in here. Grace is not correct either because it's actually 16 is the GCF of 16. And wow, I just did the whole problem wrong. This is what I get. Is a multiple of 16 and 12, but I over here, I don't know if you guys caught that. I'm going to leave it though, because a lot of times, sometimes we're doing work and we realize, oh, we made a mistake. So let's go over here and let's say we should have been finding 16 and 12. So 1 times, delete all of this. This is what happens when I look at my son while he's trying to make something to eat. So 1 times 12 is 12. Now my son is looking at me. 2 times 6 is 12. And 3 times 4 is 12. So Grace is correct. Okay? And you can tell me if you caught the error before I made it. Okay, let's go on to Angie. Angie's baking 100 cookies and 20 brownies. She wants to split them into equal groups for the bake sale. Each group must have the same number of cookies and brownies with none left over. Since you are breaking them into smaller groups, you are finding common factors. So we are going to go back here. We are going to go to shapes. We are going to make some tea tables. And the first thing we are going to do is we are going to find the factors of 100. Okay, so we could do 1 plate of 100 cookies. We could do 2 plates of 50. 100 is not evenly divisible by 3. It is evenly divisible by 4, and you get 25. Okay, 100 is also divisible by 5, and you get 20. 100 is not divisible by 6. It's not divisible by 7. It's not divisible by 8. It's not divisible by 9. It is divisible by 10. 10 times 10. Okay? Now let's go over here and let's do brownies. Okay? So the equal number of brownies, let's see, 1 times 20, 2 times 25, 3 doesn't work, 4 doesn't work, 5 works. Okay? So, your greatest common factors. She could split them into groups of 2. Okay? She could split them into groups of 5. And she could group them into, sorry, this made a mistake. This should have said 20. And she could group them into groups of 20. Okay, so those are her common factors. So we're going to make some sense of here. So if she has 100 cookies and 50 brownies, she could make 2 groups. She could make 2 plates. So this is how you have to think of it. So like 2 plates of completely. And on those 2 plates, she would have 50 cookies and 20 brownies. She wants the greatest number here. So I'm going to look at the 20 plates. So if she grouped the food into 20 plates, right, She would divide up all of the cookies, and each plate would have 5 cookies. And each plate would have 1 brownie. So sometimes when I'm doing these, I don't completely understand what the question is asking all at once. Maybe I should. So this is what I have to kind of play with it to see what makes sense. So the greatest number of groups. So it's not the greatest number of items on a plate. If it were the greatest number of items on a plate, then it would be that one. But that's not what we're asking. We're asked for the greatest number of plates. The greatest common factor is 20. If I have 20 plates and I split the 100 cookies among them, there's 5 cookies. If I have 20 plates and I split the brownies among them, there's 1 brownie. That's how I would break it up. Okay. Now, I have a little bit of a mess here. Hopefully you can see what we have going on here. The ratio of boys to girls in the homeroom is 2 to 3. So I'm going to actually say 2 to 3. If there are 8 boys, so 8 boys, how many girls? And we've done a lot of problems like this, so now you're going back to finding that common factor. How do you move from 2 to 8 with multiplication or division? It's times 4. So 3 times 4. And so there's 12 girls. Okay? Mrs. Smith has 28 6th graders and 35 7th graders. If she wants to break the 2 groups into identically sized groups without any students left over, how many students should be in a group? I'm assuming she wants some 6th graders and some 7th graders in the group. She wants to break them into the 2 groups into identically sized groups. So again, I think what they're asking for here is to use equivalent, use factors. So we're going to do that. Okay, so because the way I'm thinking, if I want to divide into groups, I would really just look at how many students I have in total. I have 28 students, and I have 35 students here. I have 63 students. So, but I don't think that's what they're asking. I think they want identically sized. So we're going to do 28 here and 35 here. I was going to try and finger write, but this finger writing is really bad, so I'm going to go back to typing. So 1 times 28, 2 times 14. 3 is not divisible into 28. 4 is 4 times 7. Okay, those are my factors of 28. For for 35. I have 1 times 35. 2 is not divisible in. 3 is not divisible in. 4 is not divisible in. 5 is 7. Okay? So my greatest common factor, my only common factor is 7. So I'm thinking that she wants to break it into 7 groups. Okay? And in each group, there would be 4. The finger writing is really tough. I don't know why I tried to. 4 6th graders and 5 7th graders. So I'm going to type all this because it's kind of making a mess. So she's going to make 7 groups of 9 students in each group. Which is 4 6th graders and 5 7th graders. Okay, If you haven't noticed, I much prefer multiples to factors, but it is what it is. And Thursday. What is the GCF of 28 and 72? We're going to keep doing these. Okay, up, up, up. Okay. I'm going to type because it works better. 28 is 1 times 28. 2 times 14. 3 doesn't go into 28. 4 does. 4 times 7. Those are my factors of 28. My factors of 72. 1 times 72. I happen to know that it's 2 times 36. Now this is where I'm going to start getting a little selective. Even though I know that 3 is a factor of 72, I know it's not a factor of 28. So right now I'm actually, just in the interest of time, going to skip 3. And I'm going to check out 4. Okay? So I'm going to come over here. Is 18. And then I know, if I look over here, I know that these have 4 in common. I know that 7 times something is not 72. And if I have my calculator, I just want to sat check the other factors of 28. 72 divided by 14. That's not a whole number. 72 divided by 28. So I can be strategic. And once I do one of these, I can just check to see which of these is a factor also of 72. And it is 4. So 4 is the GCF of 28 and 72. Taylor says that the GCF of 10 and 4 is 20. Charlie says it's 2. Who is correct? So, yep, you guessed it. We're going to make our table. Probably already have an idea of how this is going to go. So the factors of 4, 1 times 4, and 2 times 2. The factors of 10 are 1 times 10, 2 times 5. Okay. And the only one they have in common is 2. So when Taylor says that it's 20, Taylor is confusing factors and multiples. 20 is a multiple of 10 and 4. Charlie is correct. The GCF is 2. Okay. What is the greatest common factor of 40 and 60? So this is where, as I've mentioned before, I'm going to start being a little strategic. And I'm going to find the factors of 40 and then determine which of them also divides into 60. So factors of 40. 1 times 40. 2 times 20. 3 is not a factor of 40. 4 is a factor of 40. 10. 5 times 8. And then what I can do is I can just start right at the top. 40 is not a factor of 60, but 20 is a factor of 60 because 20 times 3. So as I get better at this, and as I get better at factors, I don't have to make that T-chart every single time as I start to make some sense of this. Okay. Angela has 24 golf balls and 18 golf clubs. She wants to sell packages of balls and clubs bundled together. So like we've had these before, we might have been a little confused on them. Hopefully they're starting to make sense. We're going to use factors. And if you're not sure if you're using factors or multiples in a problem, when she's dividing them up into smaller groups, that's factors. So factors of 24. Oops, 24. So 1 times 24, 2 times 12, 3 times 8, 4 times 6. That's 24, and then over here we're going to have 18. 1 times 18, 2 times 9, 3 times 6. So our greatest common factor is 6. Okay? So she needs 6 packages, and each package will contain 4, because that was the number with the golf clubs, 4 golf balls and 3 golf clubs. And number 5, I think this is a mistake. Nathan, because we had this problem elsewhere in the homework, 5 red beads to 3 white beads. Okay, so I thought this homework was a great review again this week of GCF and LCM, and hopefully this is all starting to make sense.